So I fetched a new KBR kit, kit number 3, and since I was the last one to use this one, I know this one's clean. So we'll take a little bit of our tryptamine. There's enough in there to run melting point as well as the IR, so we're okay. Doesn't take much, just a little bit. Save the rest of that for melting points. And maybe a DC mass spec. Grind that up. It's already pretty powdery. Just grind that a bit. And measure some KBR. KBR is still not the best quality. Hopefully be good enough. Mix well, grind the KBR so it's a little finer. Maybe it'll fuse better. It looks pretty powdery. Seems well mixed. We're going to transfer some of that mixture into our pellet maker. Just a couple of scoops. Just a little more. That should be enough. I'll make that fairly uniformly distributed. And gently slide it into our die. Make sure it doesn't separate. And we're going to press that down, fuse into a pellet. Break that apart. And we've got a nice fused pellet. Translucent, not transparent, but I think the KBR is still wet. I'll take that over to the instrument. Can't type today. Since I was also the last person to use this instrument, I know the chamber is empty. And I know the right experiment is loaded, so I can go directly to collecting my background. It'll collect 4 scans and show me that typical single beam spectrum with the CO2 and the water vapor. I can close that. Don't want to save the changes. And now I'm going to collect a sample. Call this recrystallized tryptamine. And it's asking me to prepare to collect the sample, which means put the sample in there and click OK. Taking its 4 scans, and we've got a decent looking spectrum with a sloping baseline again, but that's not unexpected. I'm going to save this. Set file name to title. And then I will proceed to correct the baseline. So we know this is baseline here. And there's the baseline over here. And that's probably baseline there. So that's a fairly flattened out peak. I can replace that. And I have a comment, recrystallized from hexane. This down, and now we can find peaks. I know I want these two because those two are the NH stretches, so that's going to get me a lot of peaks in this region, but that's okay. And then I'll replace that, and as always I'm going to have to go to display limits and set it from 67 to about 62 in order to get those peaks on scale over there. Took it. And I can use the annotation tool to move these guys somewhere where they're a little bit easier to see. So you can see that we've definitely got sp2 carbon hydrogen stretching in the 3030 and 3066. We've got sp3 carbon hydrogen stretching in that region from 2868 to 2976. We got some other interesting peaks. These two are the amine NH stretches. We should see peaks at 1500 and 1600 for the benzene, and we do. There's a 1592 and a 1507. There's also some other peaks in here because this is a more complicated aromatic ring. Some of these peaks are irrelevant. Some of these really small ones I'm just going to delete. And the rest of this fingerprint region should match up with the literature, even though we may not be able to determine exactly why that peak's there. This peak at 1620 is kind of small, but it might be something that matters. This peak at 867 is obviously not real. 1044 is not real. These are reasonably large peaks, 1121 and 1109. This peak here at 934, that's real. This 830 peak is going to go away. I don't care about any of these down here. These are too small to be worth taking any account with. And generally the peaks in this region in the 400 range are not something we're going to care about either. That's a shoulder. 744 is a real peak. This peak here is real. So that'll make it possible to see those peaks. And now we can save this. And that is corrected tryptamine. So let's do a library search. It thinks it's 2-ethylphenol and N-dimethyl-aniline. Not particularly good matches. 36% is our best match. So it's going to tell us that that's not a reasonable match. Obviously it's not a phenol. This peak isn't matching at all. And what that probably means is tryptamine is not in the library. We'll go ahead and print that result anyway. Call it tryptamine search. And we're going to print the corrected spectrum also. And call it corrected tryptamine. And we want to do the IR spectral interpretation, and it tells us it's a para-substituted aromatic hydrocarbon. It isn't. It's actually an indole ring, so it's a little difficult for it to tell us what it is for real. Obviously these peaks are significant, but it's not able to pick it up as an amine for reasons that are unclear. We can try to search or do that spectral interpretation on the raw data. Because sometimes it works better on the raw data. So we'll just go for the recrystallized tryptamine here. This time it thinks it's para-substituted aromatic hydrocarbon and a terminal vinyl olefin, and it is neither of those things. So there's not really any useful information to be had from the functional group search for this particular compound. We could try the library manager and go to the Nicolay condensed phase academic sampler here and type in tryptamine as text and see if it's actually in there, but I doubt it. Yep, the end of the library has been reached, so tryptamine is not in our search library. So we'll have to use the literature spectrum to use as a comparison.